What's up, guys? This is a small programming project that I've done recently, and I was just fucking around with like circles and lines and things, and ended up with this, and I thought it was really cool, so I just wanted to share it with you guys. So, what we have here is that we have 300 points on a circle, and then we have our variable jump, and I will show you now what this jump does. So, basically what we have here is that we're drawing a line from um, every point to another point. So here we have when jump is equal to 1, we are calculating which point every point jumps to using this formula here. So now that jump is 1, this is just 2i, and I is the index of the starting point of the line. So you can almost like see the pattern here. But so in the beginning, we're taking really small steps um, because we're just jumping from the first to the second, and the second to the fourth, and the third to the sixth, and so on. But as we gradually increase which point we're jumping to, um, the distance between the connecting point is bigger, so it bends inwards to the circle more. Because as said, here we have just really small steps, but if we take here, which should be approximately 75, we're jumping all the way to 150. So you can see here it tangents this inner line here approximately. Of course, and when we're changing the jumps, we're just changing how many, like the distance between the points, kind of. You can just see it in the formula here. So, um, I'm just, yeah, I'm just jumping more steps, or I'm taking a bigger index of the next point. So here we have the jump. When jump is 2, we have 3i in our formula. So we can see here at the beginning it's still like small steps, but as it's 3i instead of 2i, it increases more rapidly, and then therefore it bends inwards faster. Here you can see this like bends inwards from, okay, not really, but kind of a quarter of a circle. Consider um, um, in different in consideration to yeah, um, in comparison to this one, which it takes kind of half um, rotation. So here you can see that it takes kind of a quarter of a turn to bend inwards completely, and here it takes one half of a turn. So we can see that it bends inward faster because it's we have a bigger jump. Um, so yeah, this is basically what I had. I just wanted to show you different ones that I thought were cool. So as one would guess, the integer divisors of 300, because we have 300 points, they look really regular. So we have 6, you see it's a nice like symmetry. 7, it gets kind of weird. 8, 2, you can see almost a cool pattern inside. Well, actually, all of them have cool patterns if you look at them long enough. Some kind of pattern will appear, but they get harder and harder to see depending on the number. And how? Well, that would be really complicated, and I haven't really thought about it. But what I can say is, well, of course, that the whole integer divisors of 300, they look really regular, at least. So you can see this one is weird, this one is weird, this one isn't, because 10 is a divisor of 300. So you can just keep on going up with this. 12 is also one, so that one looks really nice. So they get kind of a circular pattern in the middle, all of them. So yeah, 15, you see it's also like a circular pattern in the middle. Um, so yeah, you see these ones look really cool, but actually like all of them do. Uh, I really find this one interesting because if you look at it closely, you see that it's like, the when the jump was one pattern, we have it inside here. And then inside of that, we have kind of an ellipse here. You can almost say that it's close to the jump is equal to one pattern. There's like a bigger one here. And then this tangents a bigger one here, which tangents an even bigger one here, which tangents an even bigger one, and so forth. So this one I really like. And then you can see like this, all of these are really cool. And I would just want to show this case also, because this is another one which looks really regular, um, but it's 37. It's a prime number, and not a divisor of 300. Um, but yeah, so and of course you can do this in many different ways. You can change the function to whatever you like. I just found this one to generate very nice looking patterns, and yeah, you can do it with like different circles. You can have like two over here, and then you connect them in different ways or something. I don't know. You're free to experiment. Yeah, here we have it again. It's like the small jump is equal to one pattern here, and then the bigger one, and then the bigger one. So yeah, I really like this one. You see that here, it's a flower inside with eight leaves. Yeah, so there are a lot of cool ones, and I shared the code with you so you can look around too and change this how you like. So well, yeah, as I said, I have a time lapse of this because we obviously don't need to have integer jumps. We can just make it like gradually change. So that is basically what I did. And I just now that I've talked enough, I'll show you this one, and you can just sit back and relax and listen to the nice music. And yeah, I'll see you next time. Bye bye.